Hi everyone, welcome back. This week's is going to be a three-parter. So we're going to have three short lessons, and we're going to focus on exploring Perlin noise. We're going to do this in a number of ways. We're going to start with just a little example to explore Perlin noise in P5.js. After that, we're going to apply Perlin noise to creating an animation, and then in the last version, we're going to create kind of a slightly fancier version of that animation. Along the way this week, we also are going to talk about adding graphical user interfaces to our programs. This is going to be a very important thing to do when we're talking about developing generative systems, because we are going to want to be able to tweak the variables in our code in order to explore a little bit some of the possibilities that our programs can provide. And creating a graphical user interface or a GUI to do this is going to be very helpful. So let's just dive right in, and let's start talking about Perlin noise. Now, Perlin noise is an algorithm that was developed by Ken Perlin in the early 1980s, I think 1982. And the reason Perlin created this algorithm was he was looking for a way to generate textures procedurally, so using computer-generated code as opposed to fixed images. The reason for that was that back then, of course, computers didn't have as much memory, and he was running into a bit of a wall trying to create the computer graphics for the movie Tron. He wanted to have more interesting, varied organic textures, and generating them on the fly using a mathematical formula was more memory efficient. Now, why Perlin noise is very useful in a generative context is that it allows us to to get random numbers that are not all over the place. Numbers generated by the Perlin noise algorithm um, are random, they're unpredictable, but they move smoothly from one number to the next. And that allows us to create much more organic randomness. So we're going to compare that in this first example to pure randomness. We're going to basically draw a line. We're going to have all the points along the line be random, and then we'll contrast that with Perlin noise and see what that looks like. So the first step we're going to do, of course, um, I've already here started a new P5.js sketch. We are going to just expand here, right, and set a black background so we're not staring at this white screen all the time. And the first thing we're going to do is just draw a line made out of a whole bunch of points. Okay, I'm going to do that very quickly. We're going to use the begin shape and end shape function to do that. What these allow us to do is between begin shape and end shape, we can draw any number of vertices or points using the vertex function. So we're going to draw a line here from left to right that's going to be made up of a bunch of successive points. And eventually we'll change the height of these points based on both noise and Perlin noise. Okay, so random values and Perlin noise. So let's set a few parameters here. We'll set a white stroke, and we will set a no fill. So we're only going to use this to draw a line, so we don't need to fill or close the shape. And inside this shape, we're going to draw a bunch of points. So we're going to write a for loop, and let's create a variable called x to count width. So x is going to go from 0 to width in increments of 1. That's going to be our x coordinate. And then for now, we're just going to make our y coordinate equal to 0. Okay? So let's run this, and what you should see here is a line going above the top of the screen. So of course we have y equals 0. For this example, let's put our y value, our 0 point for y, somewhere in the middle here. Okay, so that way we can have positive and negative values above or below the midpoint. So we're going to do this by translating the origin. We're going to leave the origin, the x at 0. We're going to translate y to height over 2, centered in our window. So now the line's going to move down here. Awesome. So this is a line, but really what it is a bunch of vertices all close to one another, right? Going from 0 to width. And we're drawing it as a line because this is between begin shape and end shape. So just a single, we're connecting the dots using begin shape, end shape. So first thing, we're gonna talk about pure randomness. So if we were to make the y coordinate, so let's let's make the y coordinate into just a purely random number. Okay, we could say let's get a random number, okay? And let's use that as the y coordinate. Our sketch is going to look like this. So now we can see there's some little wiggling here. Let's make this a little bigger. Instead of being random, between 0 and 1. Let's go from minus 100 down here to positive 100, and let's run that. Okay, so this is pure randomness. In every frame, the y-coordinate of every point along this line is purely random. And this is what this looks like, right? It's noise, and it's unpredictable, which sometimes can be useful, but it's a little bit difficult to tame, and there's no structure in there. So oftentimes it'll be very useful to get random values that have a little bit of more of a structure to them, so that while the results can be unpredictable, they will look a little bit more smooth and organic. Okay? So this can be a very useful tool. So random has its place, but by itself, it's by nature all over the place. So we're going to try to come up with we're going to use Perlin Noise as an alternative to random that's a little bit more controlled. Now, before we introduce Perlin Noise, we're going to slowly also start to add a user interface to this sketch. This is the other thing we want to cover this week in addition to Perlin Noise. So the first thing we'll do here is we're going to add a user interface so that we can control this number 100 here. That's basically like the height, right, of my drawing. It would be nice if I could control this interactively so I can experiment and just scale it on the fly without having to change the numbers. Of course, we could map this to like the mouse coordinate if we wanted to, but sometimes it's useful to leave the mouse alone and have like proper controls, especially when you start to have a lot of them. The mouse can only control 2 parameters really, so it's a bit limited in that way. So we're going to add what's called a GUI to our sketch, or an interface. There's many libraries to do that, but by far my favorite is this library called Dat GUI. It was created by the data arts folks at Google, who I believe has since been disbanded, but the library lives on. It's a great user interface library for JavaScript, and it integrates seamlessly with P5.js. So you could download the library from GitHub here in the build folder and just upload that file to your P5 editor and link to it directly. One way that I prefer to link to it, which is a little bit lazier, is using what's called a content delivery network. One example of that is CDN.js. There's a few others out there. And these content delivery networks, they're just hosting sites that will allow you to dynamically link to a library from your script directly. So in this case here, we get a link, right? We're going to take the min version, which is the minified version. It means they've taken all the symbols, all the variable names and stuff, made them super short, just so the file is smaller. You also have access to like the full version. And I'm going to copy the script tag here. Copy this script tag. This has copied the script tag into my copy paste buffer. And we're going to jump back to the P5 editor sketch. I'm going to click on the arrow above the line numbers, and we're going to go edit our index.html page. So you can see we already have 2 script tags here that are coming also from the same cdn.js content delivery network. This is used to bring in P5.js, and also by default, the editor adds the sound library, which we're not using right now, but we'll just leave it there. So below that, I'm going to paste my thing I just copied, and now it's added some extra stuff here. We don't care about that. It's linking that GUI now also as another script. So now we have 3 libraries, right? P5.js, sound, and that GUI, and then below here we have our sketch. So whenever you want to import libraries in the P5.js sketch, basically it means editing your index.html to link to other scripts. And a common way to do that is just to link to them dynamically from a hosting site like CDN.js. I'm going to save index. And now we can jump back to our sketch and we have full access to the library. So the way this library works, the reason I like it is very easy to use. First, we're going to create a variable. We're going to call it GUI for graphical user interface. And then in setup, we're going to say new dat.GUI. Okay? And we're going to create our GUI variable. And if we run the sketch, we can see this thing appears magically, a button that says open and close controls. Now, the next thing we need to do is to add some parameters to this GUI that we can change that are going to affect our sketch. And the way that we do that is we create an object that's going to hold all the variables we want to manipulate. The notation for creating objects in JavaScript goes like this. We're going to call this this object variable. Let's call it settings. Okay, I like to think of it that way. You could give it any name. And we're going to use the curly brackets because we're about to create a JavaScript object. And JavaScript objects can have basically pairs of a value name and then a value. So for example, if we wanted to make the size of our randomness here, this number 50 control included in our settings, we could say, let's create a variable called size. We're going to use column. So this is the name of the variable, and then its value is going to be 50. And you can end the line with a comma. That's a good habit because if you add more lines to your settings, you're going to want to have commas separating each variable. So now we have an object called settings, and inside of it, there's a variable called size, which has the value 50. If we want to use it in our code, we can refer to it by saying settings.size. So now this refers to, right, this variable up here. We can also say settings.size over here. Okay. So far, so good. Now, the last step is we need to connect this object to our GUI and have it add a slider that we can use to control the value of this variable. And that could not be simpler. We're simply going to say GUI.add, okay? And we're going to say use this setting objects. This is the object that contains the variables to manipulate. And we'll say add a slider for the variable size. Now we're going to use a string here to give it the variable name. So our variable is called size, so we're going to use a string called size. And then because we want it to be a slider, we're going to put a range of values. So what's the range of size? Let's say we can have it go from 1 to all the way to half of the height. Good. And magically, that GUI object is going to figure out that there is a size variable inside this settings object, and it's going to create for us a slider that we can use to manipulate the value of this variable. So it's very cool. Now I have a slider that's got a label. I can directly enter it a specific value if I want to. Awesome, right? And if I don't want to see this, I can do close control, open controls. So I can kind of collapse this. And now we've added a parameter that we can control in our sketch interactively. And as we work on this, we'll add a couple more. And we'll also keep using that library for the next few examples this week and in the coming weeks. All right, so that was a little detour through that GUI, but I thought it was as good place as any to start introducing that library. We'll see if once we add more variables, it's as simple as just adding more here, just adding more lines, and we'll do that in a second. All right, so this is pure noise, and we create, pure randomness, and we create this using the random command. Now let's contrast that to Perlin Noise. Perlin Noise is created using the noise function in P5.js. So instead of just creating some randomness here, we're going to use the noise function. Now the noise function is different from random. You don't give it a range or something like this. It's always going to return a number between 0 and 1. And the parameter to noise is where you want to sample, right, inside the noise space. And we'll explain that as we go along. It can be used in 1 dimension, 2 dimension, and 3 dimension. In this example, we're just going to use a single dimension because we just have a line. Okay? So here we could do something like we're going to take our X value and we're going to use that number, to sample inside the noise space. Okay, so imagine the noise is a landscape. We can move along that landscape and get a random number out of it by providing a parameter here. So we're going to use that as a starting point as our as our value. Now, of course, remember this returns a number between 0 and 1 always. So instead of putting it straight into y, let's create a variable called n. That's going to be our noise value. And then we're going to map n, which goes from 0 to 1. Remember, the map function is our useful Swiss Army knife of numbers. It takes an input value, which exists within a range, right? And it will map this value. It will convert it to another range that we get to specify. For example, if we know that n is between 0 and 1, I would like to sort of stretch this out to a number that goes from minus settings.size to plus settings.size, so that the y value can actually use this scaling that we set using settings. Okay. So this is what our noise looks like, okay? And we can scale it up and down. So already we can notice a few things. Now, at first glance, it kind of looks a lot like the randomness we had before. However, there's already one important distinction, which you may have noticed. It is no longer just always changing. Okay? Even though draw is still happening, right? Draw is still happening, but this is now fixed. This is the first really important property of Perlin noise. Perlin noise is unpredictable, it's random, but it works using what's called a seed. So when you start the program, there's a random seed that's created that for the Perlin noise algorithm. And from that point on, unless you change the seed, all the values that you get from Perlin noise will be deterministic, which means for a given input, you will get always the same output. It is an infinitely expandable space, which means we can use it to kind of continuously generate unpredictable numbers, but it has this property that this space that's been created here is going to be random but static for the duration of the program. And we can demonstrate that if I run the sketch again, you'll see that I'm going to get, well, it's hard to tell, but this is now a different, set of squiggles using Perlin noise because I've restarted my sketch. So first important property. The other reason this is hard to distinguish from randomness right now is because we are making big jump across this noise landscape. We are using the X value here to sample points along that landscape. And if we want to zoom in, so to speak, and to kind of take points that are closer together, all we have to do is just divide this number X here, just make it smaller. Okay? I'm going to think of that as our zoom factor. So let's create a variable here. I'm going to call it, actually, before we do, let's just try it out. I'm going to multiply. So if we want to make a number smaller, just multiply it by a decimal point. Okay, so let's say we multiply by 0.1, it's going to be 10 times smaller. And see, all of a sudden now we are kind of like zooming into this space, and we can see the points are connected using kind of random, unpredictable these like kind of peaks and valleys, but they are smoothly connected to one another. That's basically what Perlin noise does. Let's zoom in even further. I'm going to divide by 100. And now we can see we have this like even smoother change from one point to the next. Okay? So really, really cool. And we can make the zoom interactive. Just let's add a control here. We're going to say, let's add something to our settings. Let's call it zoom. And let's start with, I don't know, this seems kind of nice, this 0.01. These are obviously small values. And here we're going to say settings.zoom. Okay, so now I've made this into a variable. Sweet. And if I want to be able to control it from up here, I just need to add it to the GUI. So we'll say GUI.add settings, zoom, the name of the settings we want to change. And here we'll specify a range. We want to go from really, really small, let's say, to maybe 0.1. I'm just making it up here. Let's see what that looks like. So now we're already kind of at the close end. But I now have a slider I can use to interactively sort of zoom into this noise space or zoom out. Okay. Very neat. And now we can also set the scale if we want to. Okay. So this is the beauty of Perlin noise, right? It gives us unpredictable values that we can use to generate random numbers, but more importantly, from one value to the next, if we follow this landscape, if we use a kind of numbers that increase in the sequence in there, we know that from one value to the next, we're not going to get these huge jumps. And the kind of bumps and curves this is going to give us have this very kind of organic, natural feel to them. See, this almost looks like some mountains, right? So this is a very, very useful property, and it's going to allow us to create very interesting motion and textures procedurally that have this organic quality to them. All right, one more thing about Perlin noise. Another cool thing we can do is we can animate this space. Okay, so if these are points sampled along a landscape, this landscape goes on to infinity. So if we wanted to animate this, create an animation, we could move along the landscape simply by introducing an offset. Okay? So for example, once we've sampled a point here, if we add a constant value to this, let's say for now just like mouse X, we can we can move, right, left or right along that landscape. Now remember, we are quite zoomed in here because we are dividing by 100. So if I do steps of 1 with my mouse, I'm moving along really, really quickly. Okay, so we could add another variable here. Instead of zoom, let's call it the speed. I don't know, this is not a great name, but, and we can multiply mouse X. Let's multiply it with the speed settings. Okay. And of course, let's add this setting to our GUI as well. Let's go from, we can change the range later if we don't like it. Okay, so now this is much smoother. All I'm doing really is just dividing mouse X, right? And we can change, we can increase the speed. Now we're moving quicker across this space. We can change our zoom level, we can increase our size, right? So this sequence will go on forever. So we can use that to build animations as well. We could control the offset like this interactively, or if we just wanted to kind of keep going forever, just keep generating a new landscape, new numbers, we could replace mouse X here with a number that just keeps going up. For instance, we have frame count. Remember, frame count is a variable that just goes up by 1 in every frame. So if I use this instead, if I use frame count, now this landscape we're just kind of like slowly moving through the noise space, right, through the Perlin noise space, and we can see there's continuity, right? So there's always going to be a number generated at the end here that is smoothly varying from the previous number. We can increase the speed at which we are moving through this landscape by simply changing how much we're dividing our offset by. And we can zoom in and out of this landscape by changing how much we're dividing our coordinate, the number we use as the input, the thing that's the sequence of numbers that's used as the input. So the more we divide it, right, the smaller that number, the more zoomed in we are. Okay? And of course, in the end, this number we get from Perlin Noise is just a number between 0 and 1. So here I'm scaling it, right, using map, so that I can fill my window height and use it as a Y coordinate. So this is a very useful way to generate random values, right? We never know what's going to come out on the right side here, what's going to come out next. It could go up, it could go down, but the only thing we can count on is that it's going to create these smooth transitions, these smooth up and down peaks that have this kind of very uncanny natural quality to them. Okay? All right. So this is Perlin Noise in a nutshell, and kind of contrasted with just pure randomness, right, where things are all over the place. And also one thing to recap is Perlin Noise, once you've started your sketch, the sequence is random, but a specific point in the sequence is always going to be the same. So that's why this landscape isn't constantly changing. The only thing that's changing is new numbers as we're moving across, right? But every time I hit play, I will get a new landscape to sample from, because the program will generate a new starting seed. A seed is just a big number that's used to kind of kickstart the algorithm. So if you know the seed, you can replicate a particular outcome. So this is also another useful property. It's not always just changing all over the place, so we can also build on kind of that stability as well, and we'll take advantage of that in the next couple of videos. So that was drawing a line using Perlin Noise. In part 2, we're going to use that to create an animation, and I'll see you in the next video.